see now. Okay, derivative times. So that we would need L'Hopital's rule here. So that would be, well, actually, you know what? No, we can just divide it. So that would be the limit as x goes to 3 of x plus 3, because x plus 3, x minus 3, they cancel. So that's 6. L'Hopital also works here. And likewise, this is limit as x goes to 3, x minus 3. So that would be 0. No, that seems wrong. X plus 3, x minus 3, x minus 3. Oh yeah, you can't use L'Hopital here because it's not 0 on the bottom. Okay. L'Hopital's? Minus 2, 1 plus x minus 3. Minus 2. Cos pi over 2 is 0, so I could definitely use L'Hopital's there. Minus, so it'd be sine x. So that would be 1. And x goes to pi, sine pi is 0, so that's L'Hopital again. 1 over cos pi. Cos pi, that's minus 1. Sine pi. We'll have to check the answers. 1, but not L'Hopital's. Not L'Hopital. Bum, 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 bum. Oh, it's just 0. Limit as x goes to 0, L'Hopital, n 1 plus x, n minus 1. So that's just going to be n. And that one's very similar. Can we use L'Hopital? Maybe that's a 0. That would be, yeah, you can. Limit x goes to 0, n 1 plus x, n minus 1 minus n over 2x. That's going to be L'Hopital again. Limit x goes to 0, and n minus 1, 1 plus x, n minus 2 over 2. So that is a half n minus 1. X goes to 0, 0, 0, 0. So L'Hopital. Limit as x goes to 0, cos x minus 1 over cos squared x over 3x squared. So when x is 0, we'll get it. We get 1 minus 1. Yeah, L'Hopital again. Still recording? Okay. Minus sine x plus 2 cos x minus 3 times minus sine x. all over 6x when x is 0. Okay, so L'Hopital one more time. Minus cos x plus product rule. Fine. All over 6. Okay, derivative of the first one, so that will be 6 cos minus 4x times minus sine, so sine squared, minus 2 cos minus 2x, the second derivative. So 0 makes that gone, minus a half. Going to check that one on the calculator. Sine Yep, minus a half. Okay. That's L'Hopital again. So 376, limit x goes to 0, a half, 1 plus x minus a half, minus a half, 1 minus x minus a half times minus 1. So that's 1. 0, that's going to be 0. Okay, so that's limit x goes to 0 of ex minus 1 over 2x. And we have to do it again. Ex over 2, so that's a half. So I can take a shortcut here, because I know tan x will behave like x near 0, so I can just replace this by x over root x, which will be limit as x goes to 0 of root x, which is 0. And then this one here, log 1 is 0. Okay, so that's limit goes to 1. 1 over x, so that's 1. And then finally, this one here. So we could say that's e limit as x goes to 0, e log. So that's 1 over x log x plus 1. X goes to 0. So we could use L'Hopital, because that would be log 1 over 0. So derivative there is 1 over x plus 1. So that will be e. Let's see. How far did we get up to 380? Okay. 367. 6, 368, or 369 minus 2. And then minus 1. And then 373 n. And then what's next now? Where am I? 375 minus a half. 377 half. 379 1. And no answer for E. Okay, let's do some more now. We're on a roll. So we got up to 380. So let's see. Let's do some more. Okay. Let's try copying that again. Okay, and then okay. 381 is which one exactly now? The cube root. So yeah, let's use L'Hopital's here. Let's make the pen a bit smaller. So that will equal a half x to the minus a half minus a third x to the power, bring down the power, which is minus the third, as x goes to 1. So that would be a half minus a third. So that would be a sixth. Okay. Oh, interesting. Maybe I'll do 382 over here. So that's 381. And then we'll put 382 here. Maybe a log. E log 2x log x as x goes to 0. So that's a 0. Zero and infinity. Put this one underneath as x at a minus 1. What to do here? I saw one like this recently, didn't we? Let's think about this one. It's going to be 1. If I say L equals log x power 2x. Or I should say log L, the limit, is equal to that. So that will equal 2x times log x. Maybe that would be the same thing. Then as x goes to 0, that will become a 0. And that will become a minus infinity. But which one happens faster? So I could put it as 2 2x log x, but I'll put this 1 over x. Now I could use L'Hopital's because that's going to be this here is going to be an infinity, and this is an infinity. So that would be 1 over x times minus 1 over x squared. So multiply above and below by x squared, and we get minus 2x. And this, of course, is all as x goes to 0. So that means log L will be 0. But from the negative side, if that matters. It doesn't really, because that just means that L is 1. So that's actually what I taught, 1. All right. So that one's done. Okay, now 383. Okay. This here is going to be the same as limit as x goes to infinity of x times 1 over x, because as x approaches infinity and this vanishes, sine a small quantity behaves like the small quantity, so this will become 1. Okay. 384. L'Hopital, so that would be, well, I can see the top is going to behave like 0. So I think this will be 0. L'Hopital would say it is cos x minus 1 over 2x. Cos x minus 1 over 2x. And derivative again is minus sine x over 2, which is 0. Yeah, so yeah, what I taught, 0. Okay. Next one. 385. That will equal the limit as x goes to 0 of 4x log x, which will be limit as x goes to 0 of log x, 4 log x over 1 over x. So L'Hopital again, this is going to be 1 over x, and then this becomes minus 1 over x squared. So it'll become minus 4x, so it'll become 0. As x tends to 0. Let me just double check that one. 0. Yeah, I think that one's 0 as well. Yeah, that one's a 0. Okay, 386. 386. As x goes to infinity, this is definitely going to infinity much faster than this could ever go to infinity. I can tell straight away it's minus infinity. Yeah, for sure. Um, yeah, yeah, definitely. Okay. 387. This will go to this will go to 0 much faster than this could ever go to infinity, even with the square. But if we want to maybe have a look at that, that would be limit as x goes to infinity, x squared over ex. So L'Hopital it again. That would be ex, and that would be 2x. And L'Hopital again, that would be 2. And that would be 0 for this one. Okay, next one, 388. Am I still recording? Yes, I am. Okay, 388. Maybe I should stop it there since this video is getting quite long. So I could pick it up from 388. But let's see the answers. 387, 0. 385, 385, 0. 383, 383. That's that one there. 1, 1, yeah. 381, 381, 1 over 6. We're doing quite well. We'll continue from 388 next time. We'll go up to 387 today. I think that's enough for one video. I don't want to overload it.